In this lesson we start by creating a design for our game Earth Defender. We investigate the difference between orthographic and perspective representation. We calculate the screen height and screen width. And we discover how to access the height and width of a game object using the mesh renderer. Let's get started with this lesson. Today we start a new YouTube series. In this series we will create a game together step by step. We will call this game Earth Defender. In this game, the Earth is threatened by a shower of meteors. The aim of the game is to shoot these meteors out of the sky with a cannon. We start by making a rough sketch of the design of the game. I use the Notes app from Apple for this. But of course you can also just sketch this on paper. We start with an outline of the screen, in which the game will be located. This will later on be a fun challenge to make the game shine on different screen sizes. Then we start with our player. This is a cannon or an anti-aircraft gun. Not that I know exactly what these look like. But who cares, it's my design. The user can only move the player left or right. Meteors of different sizes fall from the sky towards Earth. If we do nothing, then humanity will be threatened by the destruction that the meteors can cause. It is up to the user to control the player and shoot the meteors from the sky. By pressing the space bar you can fire a rocket. This is our rough draft of the game. We can add additional options as we go, but we'll start with this. Let's open a new Unity project. Even though we are making a two-dimensional game, we still choose the three-dimensional template. We will be working with 3D objects. I use the 2022.3.16 F1 Unity version. I call the project Earth Defender. And I uncheck the box for Connect to Unity Cloud. Even though we selected the three-dimensional game template, we want to create a two-dimensional game. The reason for this is that we will be working with three-dimensional game objects. With the three-dimensional template, we can also simply create a two-dimensional game by changing the camera settings. The button to switch the camera to a two-dimensional image may be hidden, but you can make the game view smaller by dragging the separator bar to the right. This makes the scene view larger. The button should now appear. You will see that the image has changed. We are now looking at a right angle to our scene view. The camera can provide perspective or orthographic view. We don't want a perspective view. To show the difference, it is best to place a cube in the scene. If we then set the camera's projection property to perspective, we don't see anything special. But when we move the cube to the edge of the screen, we can see the sides of the cube. You get that effect with a perspective image. We return the cube to its origin. Now, we select the orthographic image. If we now move the cube to the edges of the screen, we only see the front of the cube. We return the cube to its origin. In a perspective representation, the view is as we experience it. In the real world, the projection lines start from a single point. This makes it possible to represent depth in a flat surface. In orthographic representation, the projection lines are parallel to each other and perpendicular to the projection plane. This does not allow you to display depth in a flat surface. We check whether the camera is set for orthographic view. Then we rename the cube to player. And we add a movement script to this cube. Open the movement script. We want to place the cube at the bottom of the screen. We can simply move it in the scene view. But now I want to do it by calculating the bottom of the screen. In the script we then ensure that the cube is moved to the bottom. Start by getting the world point of the top right corner of the camera view. The camera view places the top right corner at 1.1. Now we want to convert this viewpoint into Unity units. We create a new variable that we call Unity Unit. In the start method we use the main camera with the viewport to world point to convert the top right corner into Unity units. Now Unity Unit has the coordinates for the upper right corner of the screen. Because the center of the screen is at 0.0 and the screen is always rectangular, the top right corner is exactly 50% of the screen size away in both axes. We store the height and width of the screen in the float variable height and width. Now we can easily calculate the height and width of the screen by multiplying the Unity units x and y value by 2. Now that we have calculated the height and width of the screen, we can use this data to position the player at the bottom of the screen. We create a vector3 variable called startPosition. We give the x-axis the value 0. This places the player in the middle of the screen on the x-axis. The y-axis is given half the screen height as a value. After all, the bottom is halfway down from the origin. We also leave the z-axis at 0. Then we enter this startPosition variable as the player's transform position. When we test this in the Unity editor we see two things. The player is not at the bottom of the screen but at the top. In addition, half of the player has fallen off the screen. This is because the pivot point is in the middle of the GameObject. The first problem is easily solved by placing a minus in front of the starting position. After all, we want to move the player downwards. There is no method to directly access the dimensions of a cube, but we can access the mesh properties of the cube. This is the same size as the cube. We create a vector3 size, where we store the dimensions of the cube. Then we create a variable for the MeshRenderer. In the start method we create access to the MeshRenderer using the get component. Now we can access the dimensions of the player. Using bounds.size, we store this in the size variable. Now we can reduce the x-axis of the variable start position by half the height of the player. If everything was successful, the player will appear at the bottom of the screen. We managed to position the cube on the bottom of the screen, but we did make a mess of it in our code. Let's tidy things up a bit. I think we can move a lot of code in the start method into a function called getInStartPosition. We can call this function in the start method. Then we can close the function so that we are not distracted by it. Thanks for watching. In the next lesson we will move the player along x-axis, and we calculate the boundaries of the screen. I hope to see you back in the next lesson. Please like and subscribe, so you'll get notified if a new video is uploaded. More people will get this video in their search result when they want to learn Unity game development.